All right, well, good evening, everyone. Hello. So yeah, as Drew mentioned, my name is Ryan. I grew up in Redondo Beach, just about 60 miles down the road. So Southern California is home to me. I did go to UCLA, so any Trojan fans, the exit is right out that corner. Um, but all joking aside, I can get along with Trojans. So if you are, don't be offended. My pastor's a USC grad, so we can all get along. Um, but as Drew mentioned, also I've been at this office I've been in the Weather Service for about 15 years. Pretty much all 14 of those 15 years have been at this office with a 1-year cameo in Phoenix. So pretty much I've had it really well off as a weatherman living in Southern California. So usually the talk that I give is designed mostly for mariners, for boaters, which kind of applies to anyone who might be going out to the Channel Islands. So whether you own a boat, know someone that owns a boat, or go out to the islands, you will be encountering the marine environment. And the goal for tonight is just to understand a little bit of, one, how to get weather information if you're planning on making a trip or just going out in the water. And then two, just some of the local phenomena that we do experience in these local waters, okay? So if I do say some things that are more tailored for boaters, it's not you, it's me, okay? So just remember that. All right, let's get started. So as I mentioned, the first thing I do want to start off is a little bit about the National Weather Service. It's not really a shameful plug. It's just a lot of folks don't know who the National Weather Service are. If you lived in Oklahoma, you would know us by heart. You'd probably have us on speed dial and all on your phone. But living in Southern California, a lot of people don't know who the National Weather Service is, and so hopefully I can educate you on that. And then we will talk about the specific marine weather services that we provide to the public, and as I mentioned, some local phenomenon. And then lastly, I want to end on how you can receive our information. So whether you're on a boat or not, if you do go visit the Channel Islands, it's probably a good thing to just check the weather. The captain that's taking you out there is definitely checking the weather, but it might help you to know what you should expect if you need to bring some Dramamine or not. Not a bad idea. Oh, and by the way, that is our little bunker of an office. We are located about 15 minutes away from here on the 101 freeway. We're between the Rice and Del Norte exit, so really close to here. And that's our office. That's my boss's car right there in brown. So there you go. All right. So a little bit about the National Weather Service. We are part of the federal government. We fall under the Department of Commerce. And under the Department of Commerce exists NOAA. And within NOAA, it's actually a fairly big agency. The Weather Service is just one little arm. There's a lot of other arms within NOAA, like that does fishing regulations, marine research, things of that nature. So we are just the weather arm of NOAA. There are 120 or so offices like ours, National Weather Service offices throughout the country, and those are all depicted by the yellow dots. The closest one for this area is just down the road here in Oxnard. We also have offices in northern San Diego County in Rancho Bernardo. There's one up in Monterey and one in Hanford, which is close to Fresno. Those kind of cover the central and southern part of California. We are open 24/7, so even in Southern California, the weather never sleeps. And we have at least 2 people there all the time, 24 hours a day. We have a few national centers as well, like the National Data Buoy Center and the Ocean Prediction Center that cover. For the National Data Buoy Center, they're really the ones in charge of maintaining the weather buoys throughout the country. And then the Ocean Prediction Center does weather forecasts for way out in the middle of the ocean. And I'll talk about what we cover here in a second. So lots of different coverage, lots of coverage for the National Weather Service to meet everyone's weather needs. So our local office, we focus just on 4 counties, Los Angeles, Ventura, Santa Barbara, and San Luis Obispo County. We also cover the waters out 60 miles from the shore. So that would include pretty much all the islands here in Southern California. We break up the waters into something we call forecast zones. You'll see all the numbers 1 through 6 there on the map. So these are all areas where we will produce a forecast, kind of a general forecast for each of these 6 zones or areas. And these areas are kind of drawn where the best we can do, they don't change, but they were drawn the best that we can do where all the weather is fairly homogeneous and similar, which is really hard to do in Southern California. Like the Santa Barbara Channel, there's so many different microclimates, it's really hard to just come up with one forecast for that big area, but it's better than having 40 different forecasts that you'd have to read if you want to go 20 miles off the coast. And so it's kind of a give and take as far as making big enough zones so we just have a few of them, but also small enough where it still captures a lot of the different microclimates that we have in the area. All right, so the National Weather Service, we are a federal agency, so we love mission statements. And there it is. It's lots of words, but I highlighted the really important stuff. Basically, we exist for 2 main reasons. One, the protection of life and property. which is kind of obvious when you think about really scary kind of weather. And then second, the enhancement of the national economy, which is a little bit less obvious, and that's why we fall under the Department of Commerce. And it really falls under this idea, this is our buzzword in our agency these days, called Integrated Decision Support Services. Really all that means is that if we can tell people who have to make weather-related decisions better weather information, then they're gonna make better decisions, right? And it goes anywhere from high-level agencies like the state governor's office down to a mom dressing their kids for school that day. That's the idea. If we give them better weather information, they can make better weather-related decisions. My favorite one when it talks about the economy is one from Krispy Kreme. They actually emailed us a few years back saying that they found a correlation between the temperature and how many donuts they sell. They found that when it's hot, they tend to not sell as many donuts. When it's cold, people just love to gobble those things up. And maybe you can kind of think about yourself, yeah, I kind of want a donut when it's cold. And so if they know how hot or how cold it's going to be, then they kind of know how many donuts they need to make. So there's less waste, right? Enhancement of the national economy right there, right? That's my favorite one. In my full presentation, I actually have a slide of a happy donut salesman just to kind of hammer out that home. But yeah, so that's kind of one idea of the enhancement of the national economy aspect. And so the way that we do that is really fourfold. One, we do routine forecasts that you can pull up for any day of the year, things that you normally would expect when you want to know what the weather is, what's the temperature, what's the winds, is it going to rain? And we have a forecast program in that respect. We also have a warning program, which is more for non-routine things. So whenever the weather is concerning or hazardous or specifically noteworthy, we'll issue special products, something like a severe thunderstorm warning, a flash flood warning. A lot of these words and phrases you might see on the news or on your weather app on your phone, those all come from us. And it's really to highlight a specific weather danger that you might not really catch your eye on a routine forecast. So that's the idea with the warning program. We also are kind of a clearinghouse for a lot of weather observation in our area, and that comes not only from our own instruments, but also from other government agencies and even the general public who might have a weather instrument in their backyard and hooks it up to the internet. That comes in our system, and we can help distribute that to the world. And then lastly, it's through relationships. So we are really active in building relationships with big decision makers, those that, if they make a weather-related decision, might affect a lot of people. For example, like the sheriff of Santa Barbara County, who makes the ultimate decision on whether or not to evacuate most of Montecito. We are there feeding him the best weather intel that he can have to make the best decision. And so he will trust our forecast a lot better if he knows us, right, on a personal level. And so a lot of our time now is actually not in front of a computer, but shaking hands and getting to know people. And so that's a big aspect of what we do these days. All right, so let's talk through those 4 different points. Start with the routine forecasts. For the ocean waters, our flagship routine product is the Coastal Waters Forecast. It's boring, it's black and white. I apologize. There are some more colorful versions, but this gives you the gist of it. You probably can't read the words, I apologize, but you can just trust me when I say that it contains information that you would expect and want to know if you're going on the waters. For example, what are the winds like? What are the waves like? Is there any kind of weather like fog or thunderstorms? All that stuff will be in this 5-day forecast called the Coastal Waters Forecast. And you can obtain this forecast from our website, which I'll show you at the end of this presentation. If you have a boat, pretty much every boat has a marine communications radio, and there's a little WX weather button that you can click, and it'll actually read off the forecast. That comes from our office, and it's most of the time just reading this forecast so you can get it, it's old school technology, but it's very powerful because the reach of the radio transmissions is a lot further than cell service. So if you're 30 miles off the coast, you get no cell service, you can still get this radio signal, which is really useful. All right? And then also a lot of smartphone apps, and you can even call. We have a phone number, which I'll show you at the end too, where you can actually listen to the forecast as well. So lots of different ways to get this forecast information. So that's our Coastal Waters Forecast. We also have digital forecasts, and this is just basically a mapped out version of our forecast so that you can see on a map where we think is going to be the hottest and where the winds are going to be the strongest. And it's just another way of seeing the same information, but more in a spatially map-based version. And there are also resources on our internet and various different smart apps to get that information as well. And when I started 15 years ago, this was the newest and latest technology. Like, it just came online right when I got there. And all the forecasters are all like belly aching. Oh, this is all like new technology. We like just typing out the forecast, which is the way it used to be. And now most of our job is just creating these pictures, these graphical-based forecasts, and then we have a computer that turns those pictures into this text forecast, which is pretty amazing. Yeah. Sometimes it doesn't get it right with the words, and we still kind of clean it up, but for the most part, it does pretty good. Now, our non-routine products, our warnings, our watches, advisories, these are for mariners, for boaters, these are the different products that you might see in the various formats. And it really starts with a small craft advisory. So if you ever see on our website, or you see on a phone app, or you hear on the news, which is rare, but sometimes, that there's a small craft advisory, what that means is that these are our thresholds, that the winds are going to be somewhere between 21 and 33 knots. If you're not familiar with knots, it's very close to miles per hour. So you just add a couple, and that'll give you miles per hour. So it's kind of windy, not crazy windy, but pretty windy. And then the seas, no matter how far apart or close they are, if they're 10 feet or larger, we will issue a small craft advisory. Or if the waves are smaller than 10 feet, but really steep, like they're really close together, it's like boom, 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 we will issue a small craft advisory for that. The little flag, little red triangles, those are actually flags that will, most harbor patrols, even Ventura County is very good at doing this, that if we issue one of these, they'll hoist up one of these flags so that if you are leaving harbor and you didn't happen to check the weather, which I hope you do, and you see that flag waving, you'll know, okay, it's a small craft advisory out there, I should be careful. Or if you see two flags, it's a gale warning. If it's a square, for sure, you better turn around and come back home. So those are some of the things that's what those symbols are. Gale warning is basically the next tick up for winds, 34 to 47 knots. Fairly common in the Santa Barbara Channel, especially in the wintertime. We do get a lot of gale warnings. And then storm warning would be the next tick up from that. I've seen about one or two in these local waters where we've actually gotten that high, and it's always associated with a very powerful winter storm. And so we do get these, and we actually did have storm warning force winds on the western side of this channel this last winter, very active winter. Hurricane force winds I haven't seen on my watch, but I'm sure someday it'll happen. But that's kind of like one of those 1 in 100 year type storms that we might see in these waters. So that's kind of our standard suite of hazard products. And then on the right column, we have a special marine warning, which is really the analogous to a severe thunderstorm warning, but over the water. So if you hear on your radio or you see on our website that there's a special marine warning, then we are really highlighting a specific location where there's a really bad thunderstorm. And if you're on a boat, you want to get away from that. And it's bad because either there's a lot of lightning, there's very strong winds, or there might even be a water spout. And a water spout's just a tornado over the water, right? So you definitely don't want to, even though my dad said he drove through one time, it was a lot of fun, I don't recommend that for anybody. Okay. Sorry, Dad, if you're watching. All right. And then the marine weather statement is the catch-all for anything else. We will issue a marine weather statement if there's anything else we really want to highlight and emphasize to the general public for marine weather. That could be a general threat for thunderstorms, a really big storm that's 5 or 7 days out. We even do it if there's a hazardous oil spill. We'll issue a marine weather statement, and we are starting to do it more so with when there's a lot of dense fog out there. So if you do see something like that, that's what that is. That's kind of our catch-all for everything else. All right? So I think this is my wordiest slide, so more pictures to come. Like this one. This is a really cool photo. It really shows, this is in Ventura, and you can see the refraction where the waves actually turn. They're all coming one direction, and then when they move past the point, they actually bend. It's kind of cool. But let me talk a little bit about the local phenomena in Southern California, really focusing on the wind to start. And to start this off, let's just talk about what's common. So the prevailing or the common wind regime that we see in these local waters. If you look at the top right picture up there, because of the fact that the poles are usually really cold and the tropics are usually really, really warm, and because of how fast the Earth spins, the predominant highs and low pressure pattern on the Earth typically causes an area of high pressure at our latitude 9 months out of the year. And if you can kind of see the United States, I know it's a really small graphic, but the United States just west, just off the coast, there's a big blue H with a lot of circles around it. That's so common, it even has its own name. It's called the Eastern Pacific High, and it's there 9 months out of the year, pretty much not in the winter season. And it's really in the spring through fall season. And since air likes to go clockwise around a high in the northern hemisphere, we face go so clockwise in the northern hemisphere and counterclockwise around a low, we get over our area, over the west coast, a predominant northerly wind. That means wind blowing from the north towards the south, right? Can you all picture that around that high clockwise? We're going to get that kind of northerly winds going from the north towards the south kind of wind. And that's very predominant, especially over most of the west coast. And we definitely see that in our neck of the woods over the central coast. The bigger picture is just a snapshot of a specific day that I thought kind of personifies what we usually see in these waters. And the colors represent the wind speed, so the brighter colors are stronger winds. Kind of hard to see, but the lines are all pointed in the direction of the wind, so the winds off the central coast are pretty much pointing towards the southeast, which is when we say a northwest wind, that means that's where the air is coming from. So a northwesterly wind means the air is going from this northwest towards the southeast, and that's very common because of that eastern Pacific high. But once the terrain, the coastline makes a sharp turn on the Santa Barbara South Coast near Point Conception, the winds can't really follow the coastline like it wants to. It tries, and that's why it actually accelerates around Point Conception, and Point Conception is one of the windiest spots, if not the windiest spot in California over the waters, but it can't make that turn, and it usually just keeps on going in that direction out towards San Nicolas Island. And that's why within the inner waters, kind of off the Ventura coast and the LA County coast, the winds are actually generally kind of light. If y'all ever go to Morro Bay in the summertime, it's like blasting you in the face every time, like consistent every summer afternoon. Whereas in Ventura, it does get pretty windy, but it's not as windy as you'll experience up there. And that's really because you're not under this big dominant whole one half of the Pacific kind of weather regime. Now you're more dominated by the sea and land breezes, which I'll describe next. But that's the winds that we see over the waters off of Ventura and LA, where the winds are not necessarily northwesterly, but more from west to east, that onshore wind going from the ocean towards land, and we call that the sea breeze. You guys all heard the sea breeze before? Evidently, it's when I did a Google search on sea breeze to find some nice graphics, it's also a cocktail, and someone wrote a book on it too, so there you go. All right, so sea breeze. Let's talk a little bit about that. So the sea breeze, and that's the regime, the dominant wind regime and forcer for the winds here just off the coast of Ventura and also down LA. It's a consequence of a temperature differential, where the ocean and the land, there's a big temperature difference, especially in the afternoon. The land will heat up when the sun comes up. After several hours, the land will heat up a lot faster than the ocean, than the water, and that's just a consequence of their physical property. If you all remember back in chemistry or physics when you went to high school, which I know you just remember back, and it's right there. It's like it was like it's yesterday. Specific heat, maybe something like that. Water has a very high specific heat, so it tends to take a lot more energy to heat up, and so that's why the water temperatures are fairly pretty constant through the day. Whereas the land, you get big temperature swings. It gets a lot hotter in the daytime and cooler at night. And so during the daytime, in the afternoon, the land is fairly hot, and the ocean is relatively cool to the land. And so the cooler air wants to sink, and that causes it to compress, the air to compress, which forms a little high pressure area right there. Over the land, the warm air rises, which causes the air to expand, and that forms a little low pressure. And air likes to go from high to low pressure. And that's the same concept we all use when we tear open a ketchup packet and we squeeze it. The reason why it doesn't shoot up your arm and goes out the other end is because you're forcing a little high pressure to go when you're squeezing it, and it goes out the area of low pressure where you're not squeezing it. Yeah, I thought of that today. I don't know if that works, but all right. Based on like the blank stares, maybe it doesn't work. I'll cut that out of my routine. But that's the way that the air likes to go. It goes from high to low pressure, and that's why we have the sea breeze. And if you're over Ventura County and LA County, that means you're going to get air going from the west to the east. And that's pretty common over most of Southern California, except for the Santa Barbara South Coast and maybe Malibu. If you look on the picture on the top right, you'll see these are my crudely drawn arrows for where the sea breeze kind of goes. And for the most part, it's a predominant westerly wind, except for where the terrain, the coastline, is more oriented where it's facing towards the south, right? Can you see that on the Santa Barbara South Coast and along Malibu? Now the ocean is not to the west, which if you grew up in this area, we always just think like the sun sets to the west, the ocean is to the west. If you grew up in Malibu, well, the ocean's to the south. And that's why the winds they have a little bit of westerly tilt to it, but they're really southerly. And that's because the hot air in the Santa Monica Mountains and in the San Fernando Valley are causing all that hot air to rise, and then the relative cold air at the coast is causing the air to actually go more from the south to the north and less so from west to east. Can you kind of visualize that a little bit? Right? I know we're going back to science class, but I think we can get that, especially when you think about ketchup packets, right? Then you really understand it, right? All right. So that's kind of the common sea breeze circulation that we see here really 9 months out of the year. You're going to get that west wind near the coast. Unless you're near Santa Barbara and Malibu, you're going to get a little bit more of a southerly tilt to that sea breeze. All right? Now, that's the common kind of winds. There are a couple really uncommon kind of winds that we get that are important to the mariner, right? We get all sorts of different kinds of winds as well, but when I think about for the mariner, there's two that really come to mind, maybe three if you count the sundowners, but they're kind of similar to the Santa Anas in the way they work. But the Santa Anas, if you grew up here in this area, you're familiar with them. It's when the air pretty much blows from the opposite direction that you're expected, right? So instead, if you're facing the beach, usually you're expecting the air to hit you in the face. When the Santa Anas are blowing, it's hitting you in the back. It's a wind that blows from the east towards the west. Colloquially, we call that an offshore wind. A lot of the media folks call it that as well. So that's a Santa Ana wind. It's pretty common, like the Santa Ana season is pretty much from September to May. Most of the time we think of Santa Anas, we think of kind of late fall. And that's really important because that's usually when the big fires are, because we've had many months of no rain. All the plants are really brown and dead. When we get the first Santa Anas, it's usually really hot, and that's great if you want to be a fire because you'll get really big and grow really fast. But we still get Santa Anas in the heart of the winter after we've had a few months of rain, but they just don't get as much publicity because usually it's colder and there's a lot of moisture that the plants have sucked up. We don't get big fires, but we still get Santa Anas. And so it's a pretty large stretch for when we can expect a Santa Ana. The picture on the bottom right is a really cool picture. It's from an instrument on a satellite that measures the ripples on the sea surface. And based on the ripples at a certain frequency, if we scan them, engineers have figured out that they can infer the wind speed and direction based on those little ripples on the ocean surface. And so this picture is a result of one of those satellites, and it's hard to see which way the arrows are blowing, but they're all blowing from the right to the left, from the east to the west. And the colors represent the wind speed, and where you see those areas of red that I've circled with the purple lines there, those are where the winds are really strong. And so a lot of times we kind of think of the Santa Anas like they're really blowing out in the mountains, out in the valley, but when we get a strong Santa Ana, they can rip right through this harbor and go 20, 30, 40 miles off the coast. And so if you're a mariner, that can be still very concerning, right? We commonly issue a few gale warnings even for these offshore winds during the wintertime. So, and that's really interesting because I grew up in Redondo Beach in the South Bay of the Santa Monica Basin. And if you notice if you can see where the red is really focused over Ventura County, Malibu. But once you get into the Santa Monica Basin, basically from Santa Monica down to Palos Verdes or Long Beach, the Santa Ana winds don't really affect them because there's a huge 10,000-foot mountain range between where the wind's coming from and where the winds are going, and those block a lot of the winds. So Los Angeles, downtown LA, it's no wind and beautiful weather, right? Where I grew up, it's no wind, glassy seas, beautiful weather. But if you were to take your boat just 10 miles up the coast, it could be blowing 30 knots. And so that's why it was really interesting for me once I started to see, zoom out from my own world where I grew up, that these winds are actually pretty powerful off the coast. But they're not everywhere because it depends on where there's openings for those winds to blow through. Especially of concern would be the Channel Islands. So if boaters are going out there, or if you're taking a ferry during a Santa Ana, and if it's strong, they may cancel the trip, or it could be a real wet and wild ride. Especially if you go to Avalon, if you take a boat or ferry out there, the top left picture is of one such Santa Ana wind event. They are pretty much totally open to an easterly wind. They don't have a huge breakwall. And so when they do get these winds, if they're really strong, they can really rip up the harbor, create really big waves, as big as 10 feet that I've seen inside the harbor. And it not only does a lot of damage to the boats, but also to the coastal businesses there. And so that's something of particular note. And we have a really good relationship with the Harbor Patrol that if we're forecasting a strong Santa Ana, they'll just actually meet people coming in the harbor and they'll just say, turn around, go home. Like you shouldn't be here. This is not a safe place to be. And so we're really trying to amp up that message that if we have one, we want to tell people that Avalon Harbor is not a safe harbor. It is not a safe place to be. So for reasons like that. And there are places on Santa Cruz especially that are not safe to these type of winds. But all the boaters and the ferry owners know this. And we have a good relationship with island packers. They look at our stuff all the time. We'll talk to them if there's a big event. So they're in the know. They're one of those folks that they're the big decision makers, that their decisions affect lots of people. So they're not flying blind. They're really good at this kind of stuff. All right, and the last local phenomenon I want to talk about is a coastal eddy, which colloquially we'll call a Catalina eddy, if you've heard that phrase before. I know like Dallas Raines, when he goes on there in this teleprompter, he really likes like Catalina eddy, like he really likes to highlight that. And really what that is when we have the really strong northwesterly winds. I didn't even think about having I have a laser pointer. The northwesterly winds that move off the coast, and they don't make that turn into the channel. Whenever there's a really strong event, the winds will blow through the coastal plain here into the San Ynez Range, and then squeeze through the canyons and passes on the Santa Barbara South Coast. That's usually a sundowner, if you've heard that phrase before. And it causes a low to form right here over the South Coast. And that low is relative to a high that's in San Diego, and so the air actually wants to blow from the south to the north on this area, while they're screaming from the opposite direction over here, and you get this big circulation right here on the coast. It's called the Catalina eddy. Most associated with really bad stratus, so whenever we have a Catalina eddy, usually it's low clouds and fog all day and gloomy like this, like we live in Seattle. It's very common to get this in May and June. That's kind of the Catalina eddy season, and it really boosts the marine layer and the gloomy clouds. But why it's important to a mariner is that most mariners will go out, especially if they're making a crossing to the islands, and most ferries will really be heavily loaded for the morning hours, because that's usually when the winds are light, right? If you remember back to the sea breeze, what causes the sea breeze? It's when the land is really hot. So in the morning time, it's not. So that sea breeze is done. It's dead. So the winds are usually pretty light. But this thing actually peaks in the morning time when the winds are usually light. And so this can really catch a mariner off guard, because even though most of the time the winds are like 5 to 10 knots, not too bad, in these little places, these channels and these passages, and I'll explain why in a second, they can actually get amplified and increase. And a lot of times we'll get 15 to 20 knot winds right here in the San Pedro Channel, right here in the Anacapa Passage, where there's a lot of ferry boats and people making the crossing to go to the islands. And so I wouldn't say it's a dangerous thing necessarily, unless you're in a really small boat, but it could cause a pretty unpleasant passing or crossing, right? And so if we do have southeast winds in the forecast, and you see the mention of the Catalina eddy, I wouldn't expect calm seas if you're making a morning crossing, right? So that's the Catalina eddy. And speaking about that enhancement, there's something called the Bernoulli effect. And what that is it's basically if there's a fluid, and air is really a fluid, it's like water, it's a fluid, and it behaves like a fluid, that if a fluid is going of a certain depth at a certain speed, if you want that same amount of fluid to pass through a smaller opening, it has to speed up, right? And we've all experienced that when we water our lawns. I know it's illegal now to not have a spigot on the end of your hose, but remember the days when you didn't have to have a spigot on your hose, or a handle, whatever they're called, and how would you make the water speed up? You put your thumb over the hole at the end of the hose, right? And that's the Bernoulli effect. So we've all experienced it. That same water pressure is still want to push the same amount of water out that hose, but since you give it a smaller opening, it needs to speed up. It's the exact opposite of what happens in traffic, right? So when there's a lane missing, everyone slows down, right? But if everyone were to speed up when there's losing a lane, traffic would keep moving, right? We should institute that, right? Faster speed limits when there's a lane blocking. That might cause other issues, but still, it's the opposite. So that's the Bernoulli effect. And if you can imagine that happening on this map in these areas, like the Anacapa Passage, like all the little passages and spacings between the Channel Islands, the San Pedro Channel, the gap between San Clemente and Catalina Islands, all these little spots where the wind, if they're going in the right direction, like a southeast wind coming from here going this way, it's going to get squeezed in that passage and accelerate, just like you do with your hose. Same here in the Anacapa Passage. And same here, out here in between the islands, when we have that predominant northwest wind, the wind's going from the northwest towards the southeast, that's like perfect orientation to accelerate through these little gaps in the islands. And so we know there's really strong winds that we don't detect because we don't have buoys out there, but you can almost infer it that if the winds are fairly strong out here, it's probably even stronger over here. I hear stories from mariners all the time about that. Right? So that's one thing to take into mind if you're on a boat and you want to say, hey, let's go between the islands. Like, it's good to check the forecast. Like, if the winds are kind of strong out here, yeah, it's going to be really strong over here. There's some other areas where this Bernoulli effect happens. For example, the Sundowner area, like I mentioned before, all that air blows here into the coastal plain in the St. Ines Valley. It's got nowhere to go because these mountains are really huge, so they squeeze in through these little canyons and passes, and they kind of squirt out the other side near the coast because those canyons are like right at the beach. And so you can get some pretty strong winds that are enhanced right here over the western part of the south coast. As well for Santa Ana's off of Malibu, so like Point Dume near Zuma Beach, you get some really strong winds that go off the coast pretty well because of that Bernoulli effect. It gets enhanced through those canyons. So all things to kind of keep in mind that we've all experienced through the thumb over the hose. All right, thank you for that courtesy laugh. All right, let me mention a couple other things about the waves. I didn't mention too much about the waves. A lot of times our minds, when we think about waves, we're like, oh, how big was it? You know, what's the height? And that's really important. But periods are just as important. And so if you're not unfamiliar with the terminology of periods, really all that means is if you're sitting in one spot and a wave just passed you, how much longer do you have to wait for the next wave to come? Right? Is it 5 seconds, 10 seconds, 20 seconds? That's what period means. And so it's a time, it's in seconds usually, but it also infers a spacing between the waves, right? So if the waves are really far apart, then the periods are going to be longer and bigger, right? Because you got to wait for those waves to come to you because they're farther apart. And so what these images, these animations show is on the left side, the left image actually shows a 4-foot wave at 16 seconds, 16-second period. So this is a 4-foot wave that's fairly spaced out pretty long. There's a lot of gap between the two wave peaks. And the pole in the water is just for a frame of reference so you can kind of see when the water is rising. And if you were on a boat and you look at either of these pictures, the left one looks the best, right? It's like you just kind of ride up and down these waves. But the left side is actually bigger than the right side. The left side is showing a 4-foot wave. The right side is showing a 3-foot wave. But the period's shorter on the right. So instead of being a 16-second, looks like great conditions on the left, it's a smaller wave, but at 6 seconds, right? It almost looks like a boat wake. And you can imagine that's going to be quite a bumpy ride. And so it's really important to not only look at the height. When the waves are bigger, it's going to be bad. But also the period, when the period's shorter or smaller, it's also going to be bad, right? So you kind of have to keep both of those in account if you're going to go out in the water. Now, I'm not saying that longer periods or those, the periods that are higher or larger aren't important. Over the open waters, pretty much if it's a long period wave, it's not going to be that much of an issue. But the closer you go to the shore, it can become an issue. And so especially in this harbor here, and also in Ventura Harbor, they have a pretty persistent shoaling, which is where the bottom of the ocean kind of rises up, and they try to dredge it and make it lower again. But when the wave is just right, especially at a long period, you can get breaking waves right across the harbor entrance, and you definitely don't want to go through that when that happens. So that's a picture of Ventura. That's actually the harbor entrance on the right side, and I love the picture on the left, the Morro Bay Harbor entrance. That's a Coast Guard boat ready to go out there. Those boats are awesome. They're like designed to flip, like actually rotate underwater and flip back up. It's pretty crazy. Those guys are gnarly. But that's the Morro Bay Harbor entrance. So these are two harbor entrances that are very susceptible when it's a long period wave. But not only these entrances, but any time you get close to the coast and there's a large long period wave, you could get kind of surprised by a really large wave that comes up. And we get that happen a lot of times where boats, small fishing boats, just drift while they fish. And then they get really close to shore, and their engine may not start up, and then a big wave comes and causes the boat to topple over. And we've had people die from this. Actually, just a few years ago, we had 2 separate incidents within two weeks of each other on the backside of Catalina Island. Same thing happened. They were just drifting, and they got too close, long period swell, and people died. So long period is really important if you're going to be close to the shore on a boat. Over the open ocean, it's gold. Short period is really important, especially when you're in the open waters. Look at. All right, let's move on. Quickly about the tsunami program. So we have a tsunami program, the National Weather Service. We have a center up in Alaska called the National Tsunami Warning Center, and they're also open 24/7, which is crazy. because most of the time there's not a whole lot to do because there aren't a lot of tsunamis. They do a lot of training, though. They're still busy. But it's good because for some reason, a lot of times these things happen in the middle of the night. So I'm really glad there's someone there all the time. And they're tasked with monitoring earthquakes around the world. And when there is an earthquake, they have to quickly assess it and determine whether or not it's going to cause a tsunami. And they make the call whether or not it will or not. They're the experts. And our local office are kind of like the spokesperson. So we'll relay that information to the public and to the emergency officials and answer any questions they have. But they ultimately make the call. And so the only thing I'll say about this local area and the tsunami threat is that we do get tsunamis fairly regularly, but most of the tsunamis we get are from earthquakes that happen thousands of miles away. So by the time they come here, they're relatively small. And when we talk about a tsunami wave, we're not talking about like that classic Japanese picture with like this huge wave that's cresting and then crashing onto things. A tsunami is not so much a huge wave that's crashing, more of a surge of water. Right? So it's like a high and low tide happening in a matter of 20 minutes, as opposed to a large wave crashing onto things. So it's like a flood that's going to happen from the water rising and inundating areas. And so when we talk about a 3-foot tsunami, that means that the water level is going to get 3 foot higher than it should, and that can cause water to go deeper and cause damage, right? And so most of the tsunamis that we see in this area, the big impacts are in the harbor. So these docks that are out here are only designed to go certain water heights, and so when it gets higher, then the docks can break loose. If it gets too low, then things can bottom out. So that's really where a lot of the damage happens. It doesn't mean that this area is not out of danger for a really big tsunami. The only big threat for a large tsunami that would be like catastrophic, like go many feet inland and destroy a lot of buildings, would be if there's a really large earthquake that caused a landslide on one of the Channel Islands. There's evidence that that happened many years ago. And that's really the big threat. So what I would say is that if you live in a vulnerable area, there's the tsunami zone signs all over the community. That if you live in one of those areas, I would be most worried about if there's a really large earthquake that you would definitely feel. If you do experience a really large earthquake, then it might be a good idea to just try to go somewhere a little bit higher ground. Otherwise, most of these long-distance earthquakes, from earthquakes in Japan and Chile that cause tsunamis, you're not really going to be affected if you're on land. Right? So that's the one tip I'd give you. All right, so let me close by talking about how you can get information. How do we distribute weather information? How is it communicated? We have our webpage, which I'll demonstrate in a second. If you need to remember it, remember weather.gov, not weather.com. That's our competitors. Weather, they're not our competitors. We're all the same family. But weather.gov, it's government, right? So for government. So we have our webpage. We also are really utilizing the wireless emergency alerts, which probably most of you are annoyed with. It's that thing that at 2 o'clock in the morning you get this loud sound on your phone. You're like, I had it on silent. What I will say about that is before this technology, which is really just a few years old, we really relied upon the TV and radio EAS alerts, right? Which we're all kind of familiar with. I especially know when I was sick, I'd always watch I Love Lucy, and they'd always have the emergency broadcasting system test on the day I'm sick, or you might be watching some show and then like you get this alert and the show's getting really, really good, and all of a sudden the sound goes off and never comes back on, and people complain about that all the time. And that's really the best thing that we had. And the problem with that is that we couldn't pinpoint that only a few television or radio sets would alert. We'd have to pretty much blast it for the whole county, even if it's way up in the mountains, right? So most people get that alert like, it's sunny out, I don't care. And then maybe the people who actually need it aren't even listening to it. And so you can see the disadvantage. The wireless emergency alert system, actually what it does is that we draw, whenever we see a severe thunderstorm or a flash flood warning, something really serious, we will actually draw the area of concern. And if your cell phone is connected to a cell antenna, a tower, inside that circle, then you will get alerted. If you're not, you won't. And you can see how less people will get alerted, which is a good thing. It doesn't mean that if you get alerted that you definitely are in the threatened area, but you're really close. And especially if it's something like a flooding situation, if you already know, like a lot of the unfortunate folks in Montecito, they know firsthand that they're in a bad spot, then you know if you get that alert, like it's time to act. If you know that you're kind of in a flat area and you're not near a burn area, then probably okay. But for the most part, some people that you may know may be affected. So give them a call when you wake up and say, I was annoyed by that alert, but are you okay? So hopefully You can see some advantage to that. We also have a presence on social media, on Twitter and Facebook. Check us out there. You can get links from our webpage, which I'll show you in a second. We have phone services, which you can call. I'll give you the phone number at the end. Weather radio, which I already talked about, and we have good relationships with the news media like Johnny Mountain, Dallas Rains. I don't know if Johnny Mountain's still around. Fritz Coleman, those folks. So they're really good spokesmen and relayers of our information. All right, so to finish up, let me just demonstrate a few things on our website. This is what our homepage looks like. If you go to weather.gov, if you put a / Los Angeles, that'll take you to our local office. If you just go to weather.gov, it'll take you to the national page, which you'll eventually find our local office page. But if you're just starting, you haven't seen this page, there's a lot of information. It's a government site, so it's not the prettiest, and it's not the best organized, but all the information's there. And if you're just getting started, I would start with those 2 red squares as far as finding information. The one in the middle is a map, and if there's any shaded color for the area that you're concerned about, that means that there's something special going on. And there'll be a legend on the right, like in this example, you can see in the top left corner, there's some purple shading over the waters. You look to the right, there's a legend. You can't read it, probably in the back, but it says small craft advisory, so you know right away that area has a small craft advisory. If you're under a flash flood watch or something of that nature, then your area would be painted a certain color, and you'll know right away that something interesting is happening, right? If you want to just know the forecast, you can go to the top left and type in your city and state or zip code, and you'll get the 7-day forecast in a fairly pretty format. There's no ads, which is nice because we're the government, so if you go to a lot of other sites, there's things flashing all over the place. There's no ads there, so that's nice. And I would go there and go to town and investigate and see if you like it. Those are our Twitter and Facebook addresses if you're interested in that. And I am getting a little short on time, so let me demonstrate one thing, and then we'll speed up here. Also on the home on that map that I showed you, that color codes some special hazards. If you were to actually click on that map, you'll be taken to a forecast. So if you're a mariner and you click over the water, you'll actually be taken to that Coastal Waters forecast, that flagship black and white product that I showed you before. And you'll see the 5-day forecast in a format that's a little bit easier on the eyes for all that same information that you'd be interested in if you're going out in the water. All right? And then if there's a small craft advisory or a gale warning at the very top, it says a hazardous weather conditions, you'll be highlighted there as well. Okay, so if you're going to make a trip out to the islands, this would be a great way to start. Go to our homepage, just click in the Santa Barbara channel, and see what the weather conditions are expected to be. All right? All right, let me skip through this a little bit. Let me talk one thing about our forecast discussion. How many have ever heard of the forecast discussion before? Where are my weather nerds out there? Yes, all right, thank you. I'm a weather nerd too, so it's not an insult. So our forecast discussion, it's basically like a weather blog where the forecaster on duty has an opportunity to write their thoughts, like basically a general synopsis on the weather, but also what are some areas of concern in the forecast, like not too sure about? What's your confidence in some of the things? What are some scenarios that could happen that aren't necessarily in the forecast? You can get all that information here, which is useful to the general public, because let's say you're planning an outdoor event and the chance of rain is 20%. Like, what does that mean? Well, you might get a little insight from this thing. And so this is a really good way just to kind of get into the head of the forecaster to see what they're thinking. We also have sections specifically for marine, if you scroll down the bottom, and even aviation if you're a pilot. So there's things of that nature. So that's the forecast discussion. You can get that from our homepage. At the very, underneath that map, you'll see a bunch of icons. One of those says forecast discussion. So I invite you to read that if you're interested in that stuff. And then graphical forecast, you can also get the graphical forecast right next to that forecast discussion link that I showed you at the bottom of the page. There's a link to graphical forecast, and that's where you can see a mapped out version of our forecast as well. And then, do we have an app? A lot of people ask us that. We don't. You may see something that says NOAA Weather on your App Store or Google Play Store. That's not us. We're a government agency, so anyone's free to use our logo and name as much as they want. They're probably using our data. They're just packaging it up for you to see, and that's fine. That's great. So it's kind of our stuff, but it's not really our app. So if it breaks or it looks funny, don't email me because I have no control. But we do have a mobile page, so if you just append mobile to the end of the link here, it'll take you to our mobile page, and you can even set it up. I have instructions on there to create a little icon on your phone so it kind of feels like an app. And a lot of the information you'll find that you want to know, like you can find out the hazard information, you can get all of our products like the Coastal Waters forecast, you can see all the buoys that we have, you can even listen to the forecast that you'd hear on the weather radio, We got satellite radar data. You can read the forecast discussion. That's all available. If you go to this link, or if you go to our homepage and look for this icon under the map, looks like a little cell phone. I think it's my wife's phone I took a picture of. And you can get the weather mobile information there. So, all right. Other sites are great. I'll just say if you have your own site that you like I mentioned, go ahead and use it. It's great. We probably have our hands, whether it's our computer model or some of our information, we have our hands somewhere in it, but third-party companies have a much better way of displaying some of our data, and by all means, go for it. Like windy.com, if you've ever heard of that one, that's I like, it's just visually very appealing, so it's a nice way to see it. And they display a lot of our computer projections, so it's a good way to look at. So if you find something you have some respect for and you like it, go for it. You won't hurt my feelings. But do check our site at least. And I'll end by saying we are a federal government agency, so we are paid for by you, the taxpayer. It all costs you all about $5 a year, which is about a cup of NOAA-sponsored coffee, which hopefully you think is a good deal. So my wife and I and our family thank you for paying our salary. But with that, if there's any questions, I'll be open for that. So, thank you. All right. Yes?
Thank you very much, Ryan. That was very, very interesting.
Thank you.
A question about how winds are designated. Typically, they're designated from the direction they're coming from. But that's not true for onshore and offshore winds. Is that right? They swap it there?
Yeah. So the question was, typically we describe the winds of where they're coming from. So like a west wind is coming from the east, blowing from the west, blowing to the east. But we use those, if you grew up in Southern California, you've heard those terms onshore and offshore. I don't know the origin of them. They are incorrect, yes. We've had a professor from one of the colleges that vehemently thinks we need to change it. But unfortunately, it's so ingrained in everyone's minds, if you grew up here, that it'd be hard to change it. So we just stick with it. I don't know. But you're right. So like onshore, really, what does that mean? It's like that one kind of makes sense, like it's blowing onto the shore maybe. So maybe that makes sense. But the offshore, that doesn't make sense at all. It's almost implying that it's blowing from the offshore onto the land, right? So yeah, I don't know. It's a complaint, but unfortunately, I think most of the weather community just thinks it's ingrained, so we can't change it. Good question, though. I saw that hand back there, and then I'll come to you. Yeah.
Several things. Do you work with the military to coordinate weather such as what the naval air station for Vandenberg for missile launches? And do you coordinate with the Coast Guard for merchant shipping traffic in Santa Barbara County?
Yeah. So what kind of relationship, the question is what kind of relationship pretty much do we have with the military? We have a good relationship. So I actually just went and visited the weather folks at Point Mugu a couple weeks ago. We haven't had a good line of communication, but we are starting to. With Vandenberg, we do. We pretty much provide a forecast anytime that they do a missile launch. The military have their own weather folks, so there are people in the military that are weather forecasters. For Vandenberg, they like to see 2 different forecasts just to compare it. So we have a good relationship with them. For the Coast Guard, we also have a good relationship if there's any kind of incident, like a big accident out there, search and rescue, a hazmat. We're on the phone with them. They call us, and we do a specific forecast for that incident. So, and they read our stuff routinely every day. So we have a pretty good relationship with them. Yeah. So good question. Yeah.
Yeah, Ryan, the marine layer, is that something that's really specific to us in certain areas? And I'm wondering, was that once called something else if you were looking back in history of things?
Yeah, so the question is, what's up with the marine layer, right? Yeah, so the marine layer, I don't know if it was called anything else before, many, many moons ago. As long as I've been around, it's been called the marine layer. And the marine layer, all that really is it's a relatively thin layer vertically of that moist, cool marine air on top of pretty hot and dry air. And you really know this and experience this if you grew up around here or live here. You go to the beach, most of the time in the summertime, it's actually kind of cool, right? But if you go to the mountains, it's hot, right? It's hot, dry, and sunny because you're on top of that marine layer. And the reason why we have that here in Southern California is it's a little bit complicated, but really the main reason is that all the west-facing northern hemisphere coastlines have a lot of marine layer because they have the colder waters. If you remember the Eastern Pacific High, the winds are pretty much going from north to south. Well, the current is also going from north to south. So most of our water, our ocean water is being pulled from the north, which is colder, whereas on the East Coast, it's all being pulled from the south. So the Gulf Stream is bringing the warm water north. And so that temperature difference between the land and the ocean is a lot less because the waters are really warm. Over here, the waters are much colder compared to the land. And so as a result, we get that sinking air over the ocean. Remember I told you that the cold air is sinking, compresses it. And so that compression just above that layer, compression actually heats up the air. And that causes this thing called a temperature inversion where the temperature actually increases with height. Most of the time we think of temperature decreasing with height, right? Like we go to the mountains, we expect it to be cold. But we know in the summertime, if we go to the mountains, it's gonna be hot. Something weird's going on, right? And that's that temperature inversion where temperature is actually increasing with height because the air is sinking, compressing, and causing it to warm up. And if you remember back to chemistry, remember the ideal gas law? Remember all that? Anybody know? I forget what it is, PV equals nRT, right? There's probably some cool acronym. And if you keep everything constant, if pressure goes down, temperature is going to go down. You also experience that with like hairspray containers or barbecue canisters. When you turn on your barbecue for a long time, has anybody noticed what happens to the can of gas? Does it get hot or cold? It gets really cold, right? That's because the pressure is decreasing, and that's going to cause the temperature to decrease as well. Yeah. I haven't heard that one before. Yeah, that might be that. It very well could be that. Yeah, that's a good question. Yeah, sure. Yeah.
Could you explain the rain forecast, percentage, and accumulation?
Okay. Do you want to know if it's going to rain tomorrow? Is that the question? So the question is like, when we say the chance of rain, what does that actually mean? We give a numeric value. And the short and simple of it is that if you are interested on if it's going to rain in a specific location, that's the chance that it's going to rain at that specific location. So if we have a 30% chance of rain, there's a 30% chance of rain that's going to rain right here. That also means there's a 70% chance that it's not going to rain. And the reason why there's some uncertainty, we're basically implying uncertainty, right? We're saying that it could rain, but we don't know. We're trying to skew the odds. If we have higher numbers than we think it could rain and we think it's going to rain. I'll just say it's really hard to predict the future, right? So give us a little slack. And I love that one meme that always shows up around March Madness. If any of you do your own brackets, it's like predicting the future is hard. You know, it shows like a basketball because all their brackets are always messed up. Like love your weatherman or something like that. Because it's really hard. But that's essentially what it means. So 30% chance means that 30% chance of rain at a specific location. Why is there uncertainty? It could be either we don't know if it's going to rain or not. There could be a cold front moving down the coast, and there's a chance it just totally dissolves by the time it makes a round point conception, which a lot of times it does. But it could hold together. So there's just uncertainty on whether or not the rain's going to even happen. Or it could be that we kind of think it's going to rain, like tomorrow. I'm pretty sure it's going to rain somewhere, but it's going to be so showery. Not everywhere is going to rain. And so that's where the source of uncertainty is. Not necessarily that we don't think it's going to rain somewhere. We just don't know if it's going to rain exactly at your location. So there's different sources of uncertainty, but for you, the user, that number means that's the chance of rain that we've determined at your location. Does that kind of make sense? Cool, thanks. All right, question back there.
Related to that, what percentage of the slight chance of shower? That's tomorrow.
Okay. Wow, that's what app are you looking at for that? Oh, okay. So marine. Okay, so over the water somewhere. I think we have a little bit higher chance out here. So those numeric values, basically 0 to 100% chance of rain. We have some like descriptive words that characterize those numbers. So a slight chance is usually associated with a 20% chance of rain. Chance of rain is associated with 30 to 50% chance of rain. Rain likely is the other term we'll use. That's 60 to 70% chance. And if you just see rain, that means there's an 80 to 100% chance of rain. So these are just like descriptors if you don't like numbers, which some people don't. So that's what that means. Yeah?
You mentioned that the military has their own weather forecasters. Are there private weather forecasters, and what happens when there's like discrepancies between what NOAA does and the private people do?
Yeah, so the question was, there's the government, like us, the National Weather Service doing forecasts. There actually are private forecasters doing forecasts, and then there's military folks doing forecasts. So all these different forecasters, what happens when there's a discrepancy? That happens all the time, and that's okay, because to me, if I look at different sources and they're all saying a little bit different thing, then that actually gives you a range of possibilities and also implies some uncertainty. If they're all singing the same tune, then you should have some confidence that, hey, okay, they're all saying the same thing, and then I think that's probably what's going to happen. And so there is some art to the science of forecasting. And so everyone, like even today, I asked the two forecasters, two lead forecasters, senior forecasters, what do you think is going to rain, chance of rain in Camarillo tomorrow? Because my wife was invited to some picnic outdoor thing, right? So think of changing it. These are the kind of questions I get all the time. When I'm the most stressed, it's when like my wife asks me, is it going to rain tomorrow? Because her friend's going to cancel an event. So it's very stressful to me. But I asked one forecaster, what do you think there's a chance it's going to rain tomorrow? He said 20%. I asked another guy, he said 60%. So even within our office, we have a large discrepancy. And I think that's okay. That's part of the sciencey collaborative process of coming up with a forecast.
Either television and radio stations generally use NOAA though,
Yeah.
rather than private forecasters?
So most of them contract out with another company because they'll not only produce the numbers, but they'll make the fancy graphics that we don't do. But they all look at our stuff. They all read that forecast discussion, and there have been times when I've seen them read word for word what I just wrote in the forecast discussion. So they'll really look at that a lot. And then whenever there's something really hazardous going on, we have like chat software that we chat with them all the time if they have a question. So we have a good relationship, but the actual numbers and graphics come from a private company. Yeah. So I saw a hand over there, and then I'll go over there. Yeah.
Basically, talking about different people reporting the weather. Is everybody looking at the same data?
Yeah, so the question is, is everyone looking at the same data when they make a forecast? Yes and no. So pretty much there's a few global models that are available around the world. One that NOAA creates, and that's usually the starting point for any forecast. But then everyone has their own computer model. So a computer model is just like a bunch of physical equations that you plug into a computer, and they try to simulate what's going to happen in the future with the weather based on the laws of motion and physics and all that stuff. And so everyone has their own little local model that's open source, but you can tune it to suit certain things. And so like we have our own little local model that we might look at. So everyone has their own little local model, but everyone pretty much looks at the same starting point, but then they might look at some other data as well. Yeah, good question. You had a question back there.
Yeah, it was actually similar, just trying to learn about the process of actually doing that.
Yeah. So what do I do at my work, right? Yeah. So most of the time, what goes in the forecast process is we look at a lot of different information. If you ever come to our office, which I invite you to do, we're just down the road. If you want to come check out our office, we do tours, which is pretty crazy. Our tour facilitator is probably hating right now if he hears I'm openly inviting it because he's like scheduled out months in advance. And anyway, but we do have it open. And if you go there, we have screens everywhere because we're looking at all sorts of different data. We look at computer model projections. We look at satellite data. We look at radar data. We look at climate data because one great way to figure out the future is to see what happened in the past. And so all this sorts of information go into our brains, into our forecast, and then we come up with our best guess on what's going to happen in the future. So yeah, and the computer model thing is probably the number one driver because they've gotten really good. And we have a whole bunch of different ones to look at. And we do the same thing that I told you to do, that if all these computer projections are all saying the same thing, then we can push forward with some confidence and say, this is what's going to happen. If they're all saying something different, then we're just like, let's just come up with the best guess, So we do our best in that way. Yeah.
I took my geography class years ago in there, and one of the students that came up, I want you to verify this, if it's true. I recall that someone told us that Santa Barbara had the record at that time for heat in the United States at that part of the sundown. What's that?
Yeah.
I don't know if I could use that again or now.
So the question was that someone told this gentleman that Santa Barbara holds the record for the hottest temperature in some respect, right, in the country. And there have been reports, I think, I forget when, many decades ago that Santa Barbara was it was like 120 or something like that from a sundowner. I know even in my experience, I've seen it over 100 a couple times in Santa Barbara. So I don't know if that's true. I'd imagine it's gotten hotter somewhere, but I do remember there was some big event back then that it got really, really hot. So some truth to it. I can't verify it, yes or no. I think you had a question, yeah.
So you were talking about different models. I recall when they were trying to do a prediction for El Nino a couple years back, and it turned out, I think it was one of the government officers saying that their prediction was off, and then perhaps the European was more represented. So I guess the models are always changing too, or correlating different.
Yeah. Yeah, so all the models use pretty much the same core equations, but there's some things that you can't describe by equations alone. You have to kind of, we call parameterize or kind of rules of thumb, where a computer just can't simulate like the fine scale things. Like for example, like the way raindrops form is by little cloud droplets hitting each other and then coalescing into a bigger rain droplet. And they keep doing that until they get bigger and bigger and eventually they fall on the ground. A computer cannot simulate that because it's so small. So you have to use a rule of thumb to come up with that. So all the different models have different rules of thumb that people do their PhDs on to come up with that my rule of thumb is better than this rule of thumb. And that's why a lot of the models are different. That's at least one reason. There's a few other reasons. So the American model and the European Center for, I forget what it's called, weather forecasting, something, okay. They have their own model, and it's well recognized as being a little bit better than ours. We get to look at that data too. So yeah, there is a difference in the way that they kind of have those rules of thumb. For El Nino, there are different models, and like the big El Nino we had a few years ago, it did materialize, we just didn't get a lot of rain. And so a lot of people think, oh, well, that was a bust. Well, the problem is that El Nino did happen. The connection between El Nino, which is what happens along the equator, and what happens here in Southern California is not well understood. We can look back at 5 or 6 events that we've had in the last 100 years that were really strong, and all of those gave us a lot of rain. That one was just the one that didn't. And so most of the time, even though it's only a small sample size, we're like, okay, well, it's always kind of rained heavy before in the past ones like this, so it's probably going to rain heavy this time. And this just shows you that there's still a lot that we have to learn as far as that connection. But the El Nino did occur, and it was really strong. It's just the secondary effect of what happened here didn't. And so that means we need to learn some more, and that's okay. Yeah.
Years ago, I used to hear about cloud seeding. Is that still a viable option to produce rain?
Yeah. I don't think it's in use. So the question was about cloud seeding. I don't think that's in use very much anymore, but I know that was kind of a big idea where it's not so much, so the idea of cloud seeding is that if you have a cloud building up, one way to get that coalescing happening where those little rain droplets connect to one another and make a bigger droplet and then it falls to the sky is if we sprinkle it with like little dust particles, then there'll be a surface area for that stuff for the water to condense onto and cause a big droplet to start with, and you can get bigger droplets that way. So it's not so much that you're gonna create a storm, it's just that you're gonna make it more of an efficient rainmaker if there already was a storm. And so they tried that and they found that it helped like the rain fall by like 10% or something. But it was a pretty expensive program, and there's probably some environmental fallouts for what you sprinkle in there, which I think was like silver iodine or something like that. So I don't think they really do it that much anymore. Yeah. All right. I think I got the signal. That was it for questions. I'll be around the back if you have more, but thank you for your time, and I'll pass over to Drew.